Welcome to Lecture 12. This is Section 7.3, Trigonometric Substitution. So we've done substitution where you choose a u and it dictates a du. In this case, we're going to make a substitution that involves a trig function. So you're going to choose an appropriate trig function that's going to allow you to get out of some of these square root situations. So when you take a look at number 1, we are going to be trying to figure out how do we get out of the square root of 4 minus x squared situation. If you were to u sub for what's under the square root, your du would be negative 2x. And I don't have that. In fact, I have something worse, which is x squared in the denominator. And we know that when things are in the denominator, it gets pretty complicated. So we can't do that, okay? So now what? Well, you can't there aren't already trig functions, so it's not a trig integral. And if you try to think about by parts here, it just doesn't work. Trust me. You'd have to work with x's and it just isn't going to work. Okay, it doesn't work well. So what do? We're going to make a trig substitution here. And these suggestions for the trig function substitutions are all the way at the bottom of the page. So I'll scroll down in a second. But what you have is under the square root, you have a number minus an x squared. And when you have a number minus an x squared, down here, it's going to tell you that we're going to make a substitution for a sine theta. Okay, typically with trig functions, we use theta instead of a u. So really what we're going to do here is instead of using u, we're going to let's go back up to number 1. We're going to let x be equal to a sine theta. Okay, now our a is going to be dictated by this number. So what we want is a to be the square root of that number. So that means in this case, my a is going to be 2. So we're going to let x equal 2 sine theta. What that does then, dx is 2 cosine theta d theta. So we're going to sub that in. This is going to give me the integral of the square root of 4 minus. Now you're squaring your x. That's going to give you 4 sine squared theta. And in the bottom now you're squaring your x again. So that's another 4 sine squared theta. And then your dx is times 2 cosine theta d theta. Okay, now we've got to hopefully figure out how to simplify all this to something that we can integrate. So the first thing that we're going to do is let's pull the 4 from the bottom outside. So you've got 1/4. And then underneath the square root, I'm going to pull the 4 out of those two as well and make that 1 minus sine squared theta all over sine squared theta. And let's move the 2 out front with our fraction. So the 2 comes out there. And I've got the cosine theta, d theta. Okay, now I can use the trig function, the trig identity for 1 minus sine squared. So this becomes 1/2 the integral of 4 cosine squared theta with the square root over sine squared theta times cosine theta d theta. Okay, from here, we've got 1/2. The square root of 4 cosine theta is 2 cosine theta over sine squared theta times cosine theta. And see, right there is where the trig functions got me out of that square root situation. Okay, I was able to take the square root of the square. This gives me, bring the 2 out front, so that's 1 integral of cosine squared theta over sine squared theta d theta. Now we get into trig integrals. So this is cosine over sine is cotangent squared. Okay. And the reason I do that is because when both the thing in the numerator and the denominator are hold on, let me think about that for a second. You got a couple of options once you get into trig function about how you want to use your identities. So typically when you have a numerator that's not just a cosine d theta, you're going to want to avoid u sub at that point, right? So I would end up with a u is sine theta because you always sub for the denominator, and then you've got an extra cosine floating around. So you don't want to do that. I'm going to switch to cotangent squared. Then I'm also going to use my identity for secant and cotangent and cosecant. So we know that cotangent squared is cosecant squared x minus 1. So if I make that substitution, then I have the fact that this is cosecant squared theta minus 1 d theta. And the reason I do that is because I don't have an antiderivative for cotangent squared, but I do have an antiderivative for cosecant squared. Cosecant squared is the derivative of cotangent, so I get negative cotangent theta and minus theta plus a constant. Okay. Now, I've got to work myself backwards, right? So, how do we do that? Remember that we made the original substitution where x was 2 sine theta. Okay. That means if I solve for theta, that's x over 2 is sine theta. Okay. Now here's where things get a little bit tricky. So I can get theta by taking the arc sine of both sides. So theta is the arc sine of x over 2. So that's fine for theta. But in order to get the cotangent, I'd be taking the cotangent of the arc sine of something, and that gets a little complicated. So what we do instead is we use this information here to draw a triangle. So if this is my triangle and this is my angle theta, then the sine is opposite over adjacent. And so that means my opposite side is the numerator, which is the x. And sorry, I think I said adjacent. Sine is opposite over hypotenuse, which means the hypotenuse in this case is going to be 2. And then we can get the adjacent side by using the Pythagorean theorem. So that's going to give you x squared plus a squared is 4. So that tells you that a squared is 4 minus x squared, and a is the square root of 4 minus x squared. That shouldn't be surprising because that's actually what we started out with in the original integral. So that will come back to you. And then we want to use that triangle to find our cotangent. So we know that cotangent of theta is the reciprocal of tangent, which is opposite over adjacent. So this is adjacent over opposite. And so that means the cotangent of my theta is the adjacent side, which is the square root of 4 minus x squared, over the opposite side, which is x. And that will give us our final integral. Okay, so quite a bit going on here. Lots of trig identities, some trig integrals. We've got this triangle situation to go backwards to our x. So a lot going on here. All right, let's see another one. That one where you had a number minus an x squared, we used a sign substitution. When you have x squared plus something underneath your square root, we're going to use a tangent substitution. So you're going to let x equal to tangent theta here. And that way, when I go to sub, this is going to be the integral of 1 over x squared, which is 4 tangent squared theta, square root of 4 tangent squared theta plus 4 dx is 2 secant squared theta d theta. So my dx, and I'm just going to put this in the numerator, is 2 secant squared theta d theta. And that's what I'm going to try to integrate. Okay. All right. Now, what do we do with this? From here, we're going to do exactly what we did before. So we're going to pull our numbers out front. So you've got 1/2 the integral of secant squared theta over tangent squared theta. And then underneath the square root, pull the 4 out from the tangent squared theta plus 1 d theta. From there, we know that tangent squared plus 1 is secant squared. So I'm allowed to replace my tangent squared plus 1 with secant squared. So we're going to use that tangent squared theta plus 1 is secant squared theta. And I'm plugging that in here. So this is going to give me 1/2 the integral of secant squared theta over tangent squared theta, square root of 4 secant squared theta, d theta. Then we can take our square root. And that gives me times 2 secant theta, d theta. And now we can cancel our secants. So one of those goes with this one. And my 2 can be moved out front, and it's in the denominator, so it becomes a 1/4. And now I have secant theta over tangent squared theta, d theta. Okay. And now I've gotten myself back to just a traditional trig integral. Okay. So typically, whenever I don't have something that kind of cancels nicely, I think about switching to sines and cosines. So this is the following. 1/4, the integral of secant is 1 over cosine. Tangent is cotangent, so this is the same as 1/4 secant theta. 1 over tangent squared is cotangent squared theta, d theta. And cotangent squared is cosine squared over sine squared, d theta. And now you'll notice that one of my cosines will cancel. And I'm really looking at the integral of cosine theta over sine squared theta, d theta. And now I can use a u sub. So if I u sub for sine theta, then du is cosine theta d theta. And I can make this 1/4 the integral of 1 over u squared du. That I know the antiderivative of, which is negative u to the negative 1 plus a constant. So now I can work backwards with my substitutions. So this is negative 1/4, and these are being multiplied, by the way, times 1 over sine theta plus a constant. And 1 over sine theta is cosecant theta. Okay. Now I got to go back to x's. So remember that we had x equals 2 tangent theta. Right? Way back here. There it is. 2 tangent theta is my x. So let's divide both sides by 2. So this tells me that x over 2 is tangent theta. If I draw a triangle where I have angle theta, then tangent is opposite over adjacent. So the x goes on the opposite side, and the 2 goes on the adjacent side. And then we want to use Pythagorean theorem to get the third. So you have x squared plus, I don't know why I wrote a. That should be the 2 that's in the denominator, right? This 2 is the adjacent side, so it goes there. This x is the opposite side, so it goes there. And so we're taking x squared plus 4 equals c squared, which is the hypotenuse. And so c is the square root of x squared plus 4. Again, that same quantity that we saw above. So that goes here. Now that we've completed our triangle, we can go back and find our cosecant of theta. Cosecant, remember, is the reciprocal of sine. Sine is opposite over hypotenuse, so cosecant is the hypotenuse divided by the opposite side. So the hypotenuse is the square root of x squared plus 4. And the opposite side is x. And we get our plus c. Okay, so again, quite a bit going on here from top to bottom. This is why you have a whole page to work these out on. Okay, a lot going on. And lastly, we have what happens if you have x squared minus 4. Remember, the first one was 4 minus x squared. This one's x squared minus 4. And if we look down here, we're going to make the substitution where, and really these should be x equals, right? It should be x equals, and x equals a secant theta, right? So we're going to use our secant here. So let's try that. Okay, so we're going to let x equal, again, 2, which is the square root of this number right here, secant theta. Our dx then is 2 secant theta tangent theta, d theta. So that when we make this substitution, this becomes the integral of let's see, square root of x squared is going to be 4 secant squared theta minus 4. And the x squared in the bottom is 4 secant squared theta. And our dx is 2 secant theta tangent theta, d theta. Okay. All right, let's see what we can clean up here. Let's take our 2, which is in the numerator, and our 4, which is in the denominator, out front. So that's going to reduce to 1/2. One of the secants can go ahead and cancel. So this secant and one of those can go. And we're going to pull the 4 out from underneath the square root. So this is going to be 4 times secant squared theta minus 1. So we factor that one. And now I'm left with just a secant theta on the bottom and a tangent theta over here, d theta. Everything else canceled. Now, which identity are we using? We are using the identity that secant squared theta equals tangent squared theta plus 1. If you subtract the 1 over, it tells you that tangent squared theta is equal to secant squared theta plus 1. Minus 1. So I'm replacing what's underneath the square root with 4 tangent squared over a secant theta, tangent theta, d theta. From here, we can take the square root. So we have 1/2 integral. That's a 2 tangent theta that pops out over secant theta times tangent theta, d theta. Okay, from here, the 2 comes out and cancels with a 1/2. And we've got the integral of tangent squared theta over secant theta, d theta. Okay, what do we do now? All right, typically when you see tangents and secants, we want to cancel. But there is a trick that I can use here. And that is I can use this identity again. We know that tangent squared should be secant squared minus 1. So if I make that substitution using my identity, I can get secant squared theta minus 1 over secant d theta. From there, I can use the trick where we divide each term in the numerator by the denominator. So this can be secant squared theta over secant theta minus 1 over secant theta. I can split my fraction, right? Notice I didn't split the denominator, I split the numerators. This just becomes the integral of secant theta minus, and 1 over secant is cosine. All right, now I showed you this trick for secant. And if you can, at this point, we can just remember it. So this is the natural log of secant x, or secant theta, plus tangent theta, minus the antiderivative of cosine is sine. Okay, we got out of the integral. Now we just have to use our substitution to go backwards. So we know that our substitution here was x equals 2 secant theta. So x equals 2 secant theta. If we divide both sides by 2, that tells us the secant theta is x over 2. We know that secant is 1 over cosine. Cosine is adjacent over hypotenuse, so if you take the reciprocal, secant is hypotenuse over adjacent, right? And so that makes, when I construct my triangle, the top is going to be the hypotenuse, so that x becomes my hypotenuse, and the 2 is the adjacent side, which is this one. So in order to find that third side, I'm going to call it b. We get b squared plus 4 equals x squared. Subtract the 4, b squared equals x squared minus 4, and b is the square root of x squared minus 4. Okay, so that tells us that this side is the square root of x squared minus 4. Again, not surprising that that comes back to us. So now we need to find the secant, the tangent, and the sine. Okay, so secant, up here we have it stated right here, secant is x over 2. So we kind of get that one for free. So the natural log of x over 2. Plus, for tangent theta, we're using our triangle. Tangent is opposite over adjacent. So you're taking the square root of x squared minus 4. All over 2, which is the adjacent side. Minus the sine of theta. And sine is the opposite over the hypotenuse. So that is the square root of x squared minus 4 over x. And we add on our plus c. So trig sub is not for the faint of heart. It is quite a process, right? But our substitutions are always these, right? So if you have a squared minus x squared, and really the square roots aren't important here. It's really this part underneath the square root that you're using to make your substitution. So if a squared minus x squared, I'm letting x equal a sine theta. For a squared plus x squared, we're letting x equals a tangent theta. And if you have x squared minus a squared, you're letting x equals a secant theta. Okay. And that's going to take us to the guided practice.